Okay, here to finish up our discussion on enzymes. So up to this point, again, we know enzymes, we know their structure, we know the vocabulary, we know their behavior, their optimal conditions, optimal temperature, optimal pH. There's two slides only, kind of a short little discussion here. This is short but important. Enzymes are always instigating. Remember those little minions? They're always doing stuff. We got to get to a point where if the body no longer needs their activity, we have to have a way of turning them off. So we have to have a way of shutting down. Imagine you arrive from school, you arrive from work, you arrive wherever. You park the car and you leave it running out in the parking lot, right? Out in your driveway, whatever. That wouldn't make sense, right? You're not going anywhere. Why would you leave the car running? It can get stolen. If it doesn't get stolen, you're putting extra wear and tear on the motor, wasting gas, causing pollution. So it's not going anywhere. What do? We turn off the engine. So we inhibit that motor. Same sort of idea with enzymes. They have to be inhibited when we don't need them, right? I don't know if you've ever acted as a matchmaker. Maybe, hey, you know what? I got this friend that I think would get along with this friend. Let me see if I can get them together. And what if it worked? Okay, cool. You perfect match. It worked. But what if you didn't stop? Man, they're perfectly happy. But you know what? I'm gonna bring this person and try to get them involved with this other person and this other person, this other person. What if you just kept trying to hook up these people? It is too many. It's gonna cause chaos, right? So we got to know when to stop. And that's sort of this idea of enzyme inhibition. So enzymes must be regulated. They cannot be allowed to work all the time. If we allow anabolic enzymes to work all the time, and we keep adding tissue to the body, we're going to get huge, right? If we're having anabolic processes when we don't need them, we can start to have maybe lumps and tumors and this kind of aspect. So not good. If we allow hydrolytic enzymes to work all the time, we can now start to have too much metabolism, too much destructiveness going on. I don't know if you know somebody that has maybe a high thyroid hormone, right? So hyperthyroidism, excessive thyroid condition. So if they have that condition, their body's breaking things down too much, and you see them losing weight. So that's hormonal, but again, we associate some of those reactions to enzymes. So we have to have a way of turning off and regulating these enzymes. There's going to be two types of inhibition, right? We're going to say competitive inhibition and non-competitive inhibition. So in competitive inhibition, the inhibitor competes directly for the active site. In non-competitive inhibition, we don't care about the active site. We're focused on a different site, on another site that we call the allosteric site. So again, important vocabulary there. I think picture is going to help a little better here. So let's look at our purple enzyme. So purple enzyme, we have this hollow area that we would term as the active site. The substrate has that very perfect shape that would fit directly into the active site. All right, so the substrate is supposed to fit in the active site of the enzyme, and we should have a reaction. But what's going on here, right? What is this little blue thing? This blue thing is not the substrate. It doesn't have the actual shape of the substrate, but it has a little bit of a fit. It's got enough of a fit that it can get in there. It can kind of clog up the active site. And when that happens, now the substrate can't fit in. And we call that now competitive inhibition. The inhibitor is competing with the substrate for the active site. Now this will be temporary, right? As long as the body needs the enzyme inhibited, that inhibitor stays in. When we need that enzyme to work again, different chemical reactions can cause that inhibitor to be pulled out so that the substrate can fit in. If you've ever been, I don't know, you've been looking for a parking spot somewhere and you think the one's open, you get there and oh, there's a little cone there, or oh, a motorcycle is in a car parking spot, something like that. It's kind of like competitive inhibition. Some of you had good parents, yes? You had parents that cared about your safety. They didn't let you crawl around with these open outlets where you could put coins or paper clips in there. You get jolted. That's how we learned as kids, right? They didn't have none of these little plastic, covers, or what we call little inhibitors. So today, these kids, they can't get jolted because they have these inhibitors. They put those inhibitors and the little kids can't plug stuff in there. They can't put coins in there. So it keeps them safe, right? In the olden days, we learned the hard way, right? So we didn't have those things. So you learn right away that it's not good to put a dime in there, right? It fits, but it's not supposed to be there, yeah? So the idea of inhibiting. Now, if we look at this one over here, the enzyme is clear. The actual substrate is there. Nothing is in the active site. But what do you notice down here? So we have an inhibitor and a different site, and with the allosteric site. But once the inhibitor fits in there, it causes a change. The shape changes, right? If somebody walks up behind you and puts a pin and starts poking it through your back, oh, you're gonna change shape somehow, right? If you get poked in certain areas, you pucker up somehow, right? So it changes the shape. And if you notice these little arms on the enzyme, don't look as vertical. So they're not as vertical, they kind of close inwards, and now the substrate can't fit because the active site has been changed. The shape of the active site was changed, not by a competitive inhibitor, but by an allosteric or non-competitive inhibitor. So the moral of the story is the same. They both accomplish the same thing, they just accomplish it in different ways. Right? The same thing they accomplish is they inhibit, they stop the substrate from fitting into the enzyme, thereby they stop that enzyme and they let things kind of go back to their nice slow rates of reaction. So instead of speeding up the reaction, enzyme can't work, enzyme can't catalyze, so the reactions will happen just at their normal reaction rates, right? So I hope that made sense. And that's going to be the stopping point for the chapter 8, for the enzyme chapter.